Okay, last question, 14. Spectacle lenses can be tested by dropping a small steel ball onto the lens as shown in the diagram and then checking the lens for damage. There we go, steel ball, spectacle lens plinth. Now I don't know what a plinth means, but it's something you can put a lens on quite clearly. So, calculate density of the steel used for the ball. This is money for jam. A lot of people got this wrong. It was worrying me how many people got this wrong. But anyway, let's have a look at this. Density, rho, is mass over volume. Okie dokie. We know the mass is 16 grams. It's not 16 kilograms, it's 16 grams. So that's times 10 to the minus 3. I'm going to divide that by the volume, which is 4 upon 3, times by pi, times by the radius squared. Now if the diameter is 16, the radius is 8, times 10 to the minus 3, because it's millimeters. And it's not squared, so I said squared, it's not squared, it's cubed, pi r cubed. Once you've set that up, then it's simply a question of shoving your values into the calculator and away you go. So, 16 times 10 to the minus 3 divided by, open brackets, I'm going to do this again, open brackets, 4 divided by 3, close brackets, times by pi, times by 8 times 10 to the minus 3 cubed, all inside brackets, equals, job's a good one, 7460 kilograms per meter cubed. And think it through, be logical when you think to yourself, imagine you had a cube of steel this big, that's a meter by a meter by a meter. Visualise a meter. Is it going to weigh a lot? Yes it is. It's going to weigh more than 1,000 kilograms because that's what water weighs. Yes it is. It's going to be about 7 times the density of water. Yes it is. That's a great number to come up with. Those people who are happily writing down 2 point something times 10 to the minus 3, like what, it weighs 3 grams or something for a cubic meter of steel, just need to get your head in gear really. Anyway, that's that. Next one, in a test, the ball bounced back to a height of 0.85. First drop is 1.27, afterwards it bounces to 0.85. Now this first question says just before the impact, so let's drop in from there, just before the impact, we want to know the speed, so we're going to say mgh equals a half mv squared. We want to find out what v is. We've got m on both sides. We're going to say 2gh square rooted is going to be v. Let's shove in some numbers. Let's see what that gives us. Well, it's going to be 2 times 9.81 times by 1.27 all square rooted. Times 2 times 9.81 times 1.27 equals square root answer 4.99 or 5, whichever you want. How many sig figs is this? Let's go for 5. Alright, next one. Calculate the speed of the ball just after the impact. Well, we know it's going to bounce up to 0.85. Okay, so we can basically just say it's going to get to a height of 0.85. So we can just pretty much jump this stage and go just to here. Well, square root of 2gh equals v. Notice I'm not jumping straight for putting numbers in. I'm still doing this because I don't want to drop the ball in an exam. Square root of 2 times 9.81 times by the height 0.85. That's going to give us my v. I want the square root of, open brackets, 2 times 9.81 times 0.85, close brackets. 4.08, 4.1 ms to the minus 1. Alright, calculate the change in momentum of the ball due to the impact. Well, basically, delta P, change in momentum, is the momentum final minus the momentum initial. Doesn't matter which direction we're going to make the positive direction. I'm going to say that the positive direction is down. That means the final direction is a negative. The final momentum is a negative. So I'm going to do mass times velocity. Again, the mass isn't changing, so I'm going to factorise it like I did before. I'm going to put the mass outside. So I want the final velocity, which is minus 4.1. Because I'm in there, I've just said down is going to be the positive, minus the initial, which is 5, which goes to there, 5.0, which goes there. Then I'm going to times by the mass of my ball, which I've just calculated. How I calculated it? No, it's there, 16 grams. 16 times 10 to the minus 3. Okay, that's the change in momentum. So that's what? That's minus 9.1. 9.1 times 16 times 10 to the minus 3 gives me 0.1456. Let's round it up. 0.15 kilograms meters per second. Now, of course, you can put a minus in front of it to indicate that it's in the upward direction, but we're really only interested in the magnitude at this stage. So that's that. Time of contact is 40 milliseconds. Calculate the average force of the ball on the lens during the impact. Well, we know that F equals delta mv over t. We know the change in momentum is 0.15. We know the time is 40 times by 10 to the minus 3. That's what milli means. I'm going to leave that in there. Divided by 40 times 10 to the minus 3 equals, oops, let's come up with an error. 0.15 divided by 40 times 10 to the minus 3 equals 3.75 newtons. Job's a good one. That is that. Right, very quickly, explain with reference to momentum why the test should also specify the material, the plinth the lens sits on. Well, basically the material will affect how long it takes to bounce down. It's going to act like a cushion, isn't it? It's going to compress as the ball hits it, which is going to mean that the ball will be in contact. If it's a real hard thing, the ball will basically bounce off it quickly. If the lens plinth compresses, the ball's going to be in contact for more time. So due to compression, we'll say something like this: due to compression, the plinth will affect or alter the time of contact. Okay, and if it's going to alter the time of contact, F equals delta mv over t. So changing the time means changing the force. Changing force. All words to that effect. Alright, there you go, that's how to do it properly. Make sure you have all these improvements and all that. So if you do that, I will see you on Thursday. Okay.